Okay, guys, so let's pick up where we left off. This is going to be mostly how to do your post lab. So on labs that are coming up in the future, we won't be giving you quite this much information, but because this is your first lab, I'm going to walk you through all the details. So as we're going through them, it would probably benefit you to kind of think about what we're doing and why we're doing it. That way in the future, when we don't give you quite as much information, you'll be able to write your own conclusion and do your calculations without having to have it all spelled out for you like we'll do today. So we're back at our data table where we left off. At this point, you've already done the lab, right? You came to class, you had a blank data table, you did your experiment, you've collected the data, you've recorded it all in pen in your data table with the correct amount of sig figs, okay? So now, here's the post lab. Your post labs, in this one at least, is going to consist of basically 3 different elements. We're going to have our data analysis and calculation section. You guys are going to need to do a graph to find some overall trends. And then you're going to need to do a conclusion about the lab itself. We're going to go through and talk about each one of these individually. Here we go. For the data analysis, your basic goal here is going to be to find the density of the elements you've tested. Remember, density is going to be easy to find. It's going to be your mass divided by your change in volume. Okay, that's what the little delta symbol there means. That's this little guy. This is delta, the change in volume in milliliters. Now, important things to remember here. Every calculation needs to be labeled. For instance, if you're finding the density of lead, you need to write lead calculations. Okay? When you're finding your change in volume, that number cannot come out of nowhere. I know it's subtraction. I know you guys are pretty good at math, but you cannot just have it show up out of nowhere. Any number that shows up out of nowhere, as far as your teacher is concerned, is a made-up number, and we will completely ignore it throughout the rest of the lab. So if you want points for any of this, you better label those things and show everything. So that change in volume there, you need to show the subtraction. So you would find volume of lead, right? You take your initial volume minus your final volume. The difference there is the volume of your sample. So mass of your sample divided by your volume, that's your density. Remember your unit there, right? Mass, grams, volume, milliliters. When you divide grams by milliliters, nothing cancels. So your unit is still grams per milliliter, right? Grams divided by milliliters. That's your unit. Okay, also watch your sig figs. Remember, your sig figs may not be the same for each one of these answers. Because you used a different piece of equipment to find the volume of one of your samples than you did to find the other 2, you're going to have a different number of sig figs. Think about which graduated cylinder you used, because that's going to tell you how many decimals you had in each of those answers. Watch your sig figs all the way through, right? Addition and subtraction, remember you go by the number of decimals, whereas multiplication and division, you're going to go by the number of sig figs. So you're going to need to apply sig figs twice in each of these calculations. Once for volume, once for density. Okay. So you've labeled each of those. You've got the volume of lead, you've got your density of lead, you've got your volume of silicon, your density of silicon, so on and so forth, right? After you've found all of those, we're going to eventually need to find the percent error for the density of your germanium and your carbon. This is going to be done after you do your graph, which we'll talk about here in a second. But this is the second part of your calculation section. So you'll have a little part in here where you'll label percent error for the density of germanium, percent error for density of carbon. All right, and you find the percent error by taking your experimental value. That's what you're going to find off of your graph. You're going to subtract it from the actual value, which I will give you. In fact, it's right here. Okay. Oh, let me see if I can stretch this out so you can see the bottom one there. There we go. There's your actual density of carbon and germanium. Okay. So experimental value minus your accepted value. That's this one right here. Divided by your accepted value multiplied by 100. That's your percent error. Okay. Now you can have either a positive or negative percent error. Some people will tell you to find an absolute value, but that's not necessary here. Positive or negative will actually be helpful for you later to determine why you went over or under in certain labs. Everybody good there? Okay, so here's your graph. To construct your graph, you're going to do density versus atomic number. That means we're going to put density on our y-axis. We're going to put atomic number on our x-axis. Both axes will start at 0 in this case. We're going to make a best fit line through the data. And then we're going to use the graph to find the density of germanium and carbon. Now, Since germanium is inside of your collected data, we call that interpolation. Hopefully you remember that from your graphing intro way back a couple units ago. The density of carbon you're going to find by extrapolating. That means you're going to have to draw your line outside of your collected data, right? And remember, when you're extrapolating, you do not use a solid line. You need to use a dotted line when you're extrapolating, okay? Remember to include all the proper markings and labels and all that kind of stuff, okay? And follow all your graphing techniques that we've taught you throughout all of our graphing experience. Okay, after you've gone through on your graph then, you found that germanium value, you found your carbon value, you found the percent error for all of those. Finally, you're done with all your calculations, you're done with your graph. The last part you need to do is your conclusion, okay? In your conclusion, you're going to look at your results and you're going to summarize everything, okay? So the first thing you need to do is look back at your purpose. Your purpose was what you were trying to answer. You should start by answering your purpose. What did you find? What was your conclusion? Restate what you did and the results. Remember, in any lab where there's a numeric answer that correlates to your results, you need to actually cite that number. That number needs to be written in the conclusion. Okay? So you're going to tell me what those values were that you found for the densities of germanium and carbon. Okay, so we restate. We talk about the densities we found for germanium and carbon. You need to explain to me how you found those densities. Okay, there's certain assumptions that have been made there. There's certain techniques. You need to explain those in your conclusion. You can't just throw a number in there and not explain where you found it from. So explain it. All right. Finally, you need to discuss your results. In the discussion of results, you need to tell me whether you think your results were good or bad. Cite your percent error. Your percent error was blah, blah, blah. Is that a good percent error? Is that a bad percent error? How accurate do you feel your results were? And here is the tricky one that throws people off all the time. When you tell me what your percent error was, you need to stop and turn on your brain and actually think. What are some legitimate reasons that could have given you an error? Okay? What was something that would account for the fact that your density was too high or that your density was too low? A legitimate reason that actually matches your results. If your results came in lower than the actual values, you need to give me reasons that would account for a lower amount. This is very hard for most Chem 1 students. You need to really stop, take some time, and think about it. What specifically could have you measured wrong that would have given you the wrong results? What specifically could have you done wrong in your procedure that could have given you results that match your error? Or perhaps even in your graph. Now, be very specific on those. Do not be general, do not be vague, don't give me human error. That's not specific, that's not legitimate. Okay? Finally, give me an example of what you could do to improve the results of your lab. Okay? A legitimate improvement that would actually give you better data and reduce your percent error. Think about it. Takes a little bit of time. Use your brains. You can do it. Okay, folks. That about wraps up your post lab. Good luck on everything. If you have any questions, come in and ask your teacher during the day of your lab. Or through email if you really need to. Before school, whatever. Just make sure you have these things done. They will be due the day after your lab. So you have the night of your lab to finish writing these up and bring them on in. Good luck with everything. I hope your first lab goes well.